So good evening, everyone. So welcome again to this monthly APOD session brought to you by Astronomical Society of Penang, ASP. So yeah, as usual, the last Saturday of every month, we will have this APOD discussion session or APOD sharing session, which is APOD, which stands for Astronomy Pictures of the Day, which is a website helped by NASA to share one astronomy image selected every day. So today, with us, we have, as usual, me, Lai, all right, a committee member of Astronomical Society of Penang, and Dr. Chong, our president of Astronomical Society of Penang. Both of us are the regular presenters for APOD every month. And also for this month, we have our two invited guests, which is Mr. Chui Zhechin. All right, Zhechin is currently in Johor, and he's a student in this college, Tuanku Jaffa. So he was with us last APOD session, and he also was with us on the last Astro Cafe session because he went to Romania in the year 2019 to represent Malaysia joining this International Astronomy Olympiad IAO. And the best thing is he won a bronze medal. So he's actually very expert in this astronomy. So yeah, without wasting more time on introducing Jachin, if you are interested, you can go to have a look on our playback of this interview with Jachin and his team on the Astro Cafe session this month, on this month, July, which is held 2 weeks ago. And also with us tonight, we have Mr. Sunit Singh, the former Chongling Astronomy Club president. He had just finished his Form 5, finished his SPM this year. And he had enrolled in A-level studies in a college in Penang, is it? Penang? Inti College Penang?
Inti Penang.
Yeah, in Penang. So he will pursue his career maybe in astronomy or in this space technology, space engineering. So we hope for the best for him. All right, so let's start with the APOD today. Right, so let me share my screen. So let's see what we have for APOD today. So can you see my screen?
Yes.
All right. So APOD today is 26th of June 2021. So the title is Pixels in the Sun by Wang Letian. Is a astrophotographer from China, Beijing. So there are two photos over here. All right, actually it's a 2-in-1 photos, which is the sun captured using hydrogen alpha telescope. All right, so over here we can see the sun. All right, we have some small sunspot, some tiny sunspot. We have some solar prominence. All right, some solar prominence, and then we also have this solar flare, right? Solar flare, which is this bright spot, a sudden flash increase in this brightness of the sun, and usually appears near to a sunspot. But this is not the special point of these photos, all right? Even though we know that for the past few years, our sun is like quite inactive, or I'll use the word, our sun is in a sleep mode or hibernate mode. And recently it just woke up and you start to see this solar flare or sunspot from recent observation. You can start seeing sunspot. So the sun is waking up. But then the main interest of these two photos, the top one is the transit of the China space station, Tiangong space station, and the bottom one is the transit of International Space Station, ISS. So this is a single shot, all right, for this China space station. So it's relatively small because the China space station was launched recently, I think earlier, a few months ago on April, 29th of April. So the core module had just launched, this is the Tianhe module, the core module. But ISS is basically complete, have been built completely. The whole spacecraft is completely built. So capturing transit of ISS or capturing transit of this space station is actually more difficult compared to capturing a total solar eclipse, because this is even rare compared to a total solar eclipse. Why? Even though we know that ISS or space station is in this low Earth orbit, which the period for one revolution orbit around the Earth is 90 minutes. That means one day it will have 16 orbits around the Earth. But the visible region is actually very small. So if you realize, right, this is the most recent pass through Penang. Only a small part in Penang Island can see the transit of ISS. And the time is very short. It's just 1.3 seconds. So the challenge of capturing image of ISS transit is more difficult. And usually ISS transit, we can see the image is something like this, all right? They will use a high resolution CCD camera and then stack the image together. So you can see ISS like this, the transit. Okay, it's not necessary go this way. It can go the other way. For example, go this way or this way, depends on our location and orientation. So this is it about 26th of June. Next, I will pass over to Sunit for the next presentation. Is it Sunit or Jashin?
Sunit, you're on 22nd of June?
Yes, me.
Yeah, 22nd of June. All right, so I'll stop presenting. Thank you.
Okay, can you see?
Yes, can see, Sunit.
Yes.
Okay, so hello everyone, good evening. So I'm Sunit, and right now I'll be presenting the APOD for June 22nd. Okay, so okay, so this is the APOD for June 22nd and has a title of HD 163296, Jet from a Star in Formation. Now, this image is captured by the VLT, Very Large Telescope, and MUSE, Multi-Unit Spectroscopic Explorer, ESO, the European Space Agency. And then ALMA, which is the Atacama Large Millimeter Array, ESO's, ESO's European Space Agency, NAOJ, National Astronomical Observatory of Japan, yeah. And NRAO is National Radio Astronomy Observatory, yeah. So in this picture, what we're looking at is actually that this picture is actually consists of two different wavelengths. And if we look at the center part, you see this orange thing, orange disc forming, and that's actually in radio waves. Now that orange thing is actually a newly forming star, which is a very young star and still in a process of formation. And this star is located at the constellation of Sagittarius, and it's about 330 light years away. Okay, so what we see now is we can see the this is actually expelling a lot of jets perpendicularly from it. So what are these? This is actually that so when a star is about to be formed, it will spiral a lot of gas, hydrogen gas, and it will just expel all the gas in very high speed and perpendicularly to the disk. And so this solar system might be formed about 330 years ago, because this star is about 330 light years away from us. And so for this central part, the orange part, which is taken in radio waves, is actually taken by the Very Large Telescope, in Chile, and this blue or this hydrogen gas or this blue color are actually taken from the ALMA telescope, which is also located in Chile. Okay, so this jet, they are all expelled in a perpendicular direction because that the magnetic field of the star actually ensured the jet to be expelled in this one direction. So when we look at this image, is actually a this two-dimensional image. We will not feel that like this star is actually like expelling the gas in two different directions. But if we see it through a 3D image, this star is actually facing away, towards the darkness behind it. I don't know, but the jets are actually expelled up and down in two different directions. All right, so this is it for June 22nd. So right now I will move on to the next APOD. Okay. Okay, so now this is the APOD for June 19 and has a title of Northern Summer Twilight. Now this image is taken by Justin Anderson, which is a astrophotographer from Canada, but Justin more like to take pictures of aurora more, but he also usually take pictures like these night skies. Okay, so what do we see here? Okay, actually this picture consists of one image of the background, 8 image of the foreground, and if you see closely, there's this little tiny yellow dots, and all these dots are actually fireflies, and he took about 950 photos for these fireflies. So actually what you see here is also, you can see twilight at the background. So what's a twilight? So Justin, he's from Canada. There's a place called Brandon, which is in the Manitoba, yeah, and that place is very far north from the equator. So right now we are also at in the mid June, which is the summertime in the northern hemisphere. So if you go to very far north of the very far north from the equator, we can notice that when the sun it rises, and there's one day that the sun will rises and that the sun will not set. This is due to that because our Earth is tilted about 23.5 degrees. So when when the Earth, when the northern hemisphere is pointed toward the sun, more of the northern hemisphere, the surface of the northern hemisphere, is shined by the sun. So means that people living in the northern hemisphere during the summertime, they will be exposed to more sunlight, and there's at least one day that they will have totally 24 hours sunlight, and when it's about to be midnight, this is what they see. So we can also see that there's this Nauticus Clouds over here, aka we also known as night shining clouds. So it means that the sun, which is right now below the horizon, is the sun actually can shine those clouds, because you can see that the clouds are bright over here, and so we can see that the sun actually can shine the clouds because the clouds has about maybe 80 kilometers of altitude. So it means that if we are at a higher altitude, like maybe at the level of the clouds about 80 kilometers from the Earth's surface, we can still see the sun, even though the sun has not yet rise when we're at the ground. So it means that the higher we are, the earlier we can see sunrise. And also, if we are also at a very high altitude, the later means that when the people at the ground has already witnessed the sunset, we at a very higher altitude, we can see the sunset for about few more minutes. Okay, so this is it for APOD for June 19. So next I'll move on to the next APOD picture, which is the APOD picture of June 18. Okay, so what do we see here right now? Okay, so this is an image and has a title of Devil Horns from a Ring of Fire. So as you can see that, well, these things looks like a horn from a devil, but this is actually not a devil's horn. It's a sun. And this picture is taken during the solar eclipse of 10th of June. Yeah, which is the most recent one. And the solar eclipse can be seen at the very far northern hemisphere, Russia, Canada, the east coast of United States, Greenland, and etc. Okay, so we all know that the sun is actually is a circle, but why do we see that? Why the sun looks like it's not a circle, but it's like oval shape and ellipse shape? So because that there's a thing called atmospheric refraction, where when light enter to the atmosphere of the Earth, the light is actually refracted. So after that, the refracted light will enter to our eyes, and so we will see a picture like this. This is the sun's right now is extremely distorted, because actually right now we're looking at the horizon, and if we are looking at the horizon, we'll be looking at we'll be looking through a lot of atmosphere in our Earth. So the light particles coming from the sun, that's coming from the sun and towards the Earth, will be refracted a lot of times, and then the image that is formed in our retina will look like this, and the sun is very extremely distorted. So this picture is taken by Mathur Rati, and is a astrophotographer from New Jersey, United States. And right now this eclipse is about, the obscuration is about 71.1%. So that's it for APOD of June 18. So next I'll move on to APOD for June 15. So the APOD of June of 15, Jurong, New Rovers on Mars. Now this is a very, how to say, this is a very popular news right now, because China has already landed a rover in Mars, and this rover is called Jurong, or in Chinese we call it Zhurou. So Jurong, the name comes from a Chinese mythology story. So it's come from a name for a god of fire. Okay, and because the planet Mars, if in Chinese, is translated to the planet of fire, 火星. So yeah, it makes sense that the name of the rover is called Jurong, the god of fire. Okay, so the rover is actually launched by a rocket called the Tianwen 1 or Tianwen 1号, and it was launched at last year, the 25th of July. Yeah, and then the Jurong rover landed on Mars this year on May 14th of May. Yeah. So what's the main purpose for this rover to be on Mars? Well, the main mission for this Jurong rover is to study and maybe discover the existence of water in Mars. So the mission of this Jurong, it will take about 90 days, and hopefully after the 90 days mission to collect rock samples and discover the existence of water, he also can survive more than 90 days, like Opportunity rover, the Spirit rover, and Perseverance rover. Okay. So for this Jurong rover, China actually implemented a radar inside this rover, and this radar is like an underground radar to detect the ice below the surface of Mars, because it was believed that about decades or thousands of years ago, or many years ago, there's a river on Mars and also some waters on Mars. But why all the water and the river on the Mars are gone? It's because the planet Mars is actually smaller than Earth, so the planet Mars doesn't have a really strong atmosphere. And because due to the insufficient atmospheric pressure of Mars, it cannot allow water to exist on the surface of Mars. But water can still exist on Mars, but it was buried underground and it was in a solid form, which is ice. Okay, so I think that's it for me, and I'll pass to Jakin, right? I think the next is Jakin. Okay.
Yeah, so hi everyone. Let me present my screen first. Okay, first up we got June 20th, sunrise solstice after over Stonehenge. So, okay, this is a very special photo on a very special day because June 20th is the summer solstice. It depends on which time zone you are. Usually, we will say it's like June 21st, but in some areas of the world, it starts on June 20th. And the reason why this photo is also special is because that in the Stonehenge, it's not just a tourist attraction, it's not just a historical site. It has a very important significance in astronomy as well, because the researchers have found out that uh, the entire Stonehenge is actually oriented towards the sunrise during the solstice at that time. Because remember that the at different seasons, at different uh, times of the years, and the direction of the sunrise actually changes. And if you track the position of the sun throughout the years at the same time, you'll notice that the sun actually traces out at 8. That's called the analemma. But we will talk about that in the future, I hope. So yeah, this is a very beautiful picture taken by Max Alexander. And next we have June 14. Okay, so this is a moon, but guess what moon is this? Get which moon is this? Which planet does it belong? And the I can give you a hint, which is that this is the biggest moon out there. Okay, so this moon actually belongs to the biggest planet we have, which is Jupiter, and it's actually even bigger than our moon, and it's even bigger than Mercury. So yeah, it looks quite similar to our moon, but if the surface is totally different. The surface of this moon for Ganymede uh, is actually ice. It also has craters as well. And what's interesting about this photo is about these dark grooves. So if you look at the description, the dark grooves is still a topic of research, but some people say that it's because of the shifting of ice plates on the surface of the Ganymede, which is similar to how our continents drift over time. So this is taken by NASA, the spacecraft Juno, which is currently an active NASA project studying the planet Jupiter. Yep. So now I'm gonna pass over to Lai.
Yes, so it's me, right, again. So let's continue with the APOD on June 11, right? So let's see. June 11. Now, this is a nice image, all right? So it's a partial solar eclipse, right? So remember last month we have this lunar eclipse. So usually after a lunar eclipse, not long later, we will have a solar eclipse. And this solar eclipse is on 10th of June, which is an annular solar eclipse. But it's like if you are aware in Malaysia, like you did not receive any news about this annular solar eclipse because it is not visible in Malaysia. So before we discuss about these photos, let's take a look on this visibility map of this annular solar eclipse. So we can see the visible region is actually on the northern hemisphere, but to observe the whole eclipse, you can see is only on the polar region. And then northern part of this tropic area, you can see partial solar eclipse. Like northern part of China, western part of America, you can see this you can see partial solar eclipse. In Malaysia, Malaysia is over here, is outside the visibility range, so we cannot observe this solar eclipse. But we cannot observe that. We don't have the chance to we don't have the opportunity to enjoy this solar eclipse. But then we have the opportunity to enjoy the photos. All right. So let's see these photos taken by Zeph, who was a very, very young American photographer. All right. He's a professional, I would say a professional photographer who take a lot of beautiful pictures. If you happen to go through his blog, a lot of interesting pictures. And he's very young. I think just slightly over 20 this year. All right. And yeah, so let's see. This is it. On June 10th, which is a bird flying past. Sorry, a bird flying past through, or we call it a flyby. All right, flyby. This is a single bird. All right. This is only one bird fly by the partial solar eclipse, okay, which is partial solar eclipse. So the eclipse is visible in the morning. So this is early in the morning. This image is captured. All right. So we can see over here. All right. This is a single bird flyby. So this is even rare than ISS because you don't know whether you can success in capturing this image or not. So the APOD we see just now, I shared with everyone just now, which is a single shot, which is you see the space station or the ISS, only one in the single. But this is a multiple shot. You can see a multiple shot where the bird's motion, you can see the motion of flapping the wings and the motion from flying from the left to the right. And another interesting thing about this image is that this is the position of the sun and the moon. The position of the sun and Earth. All right, that means our Earth just passed through our apogee. That means the furthest distance from the sun to Earth 2 days ago. So before 10th of June, we are at the apogee. That means we are furthest away from the sun. But 2 days later, so happened that we have this annular solar eclipse. All right. So this is it for 11th of June. So next, let's proceed to the next one, which is APOD 10th of June. So yes, this is called a solar halo taken by a Italian astrophotographer named Vincenzo Mirabella. All right, Vincenzo Mirabella. So this is a solar halo. A lot of people actually confuse a halo and a rainbow. So a halo and a rainbow is two different things, okay? Although both looks like rainbow. All right, although both looks like rainbow. So just to share a little bit, last year when ASP we conduct this astronomy quiz for secondary school students, there's a questions regarding rainbow, and many people are confused rainbow and halo. So which they actually did a mistake on that particular questions. So be clear, okay? Be clear that rainbow and halo are two different things. All right. How different are rainbow and halo? First, the source or the interaction of the sunlight and the atmosphere, the source of the halo or the source of rainbow is different. For rainbow is the interaction of sunlight with water droplets or water particles, water molecules suspending in the air. So the source of rainbow is water droplets. All right, it's water. But for halo is different. For halo is ice crystals. So that means for rainbow you can only see it 2 times. All right, there are 2 times in a day you can see a rainbow, whether in the morning or in the afternoon, in the evening. All right, before sunset. But you never able. It's impossible for you to see a rainbow in the noon time, 12 p.m. in the noon, and you look up, you will never see a rainbow. But it is possible for you to see a halo. All right, because rainbow it involves reflection, but halo it does not involve reflection. So halo is always not to say it does not involve reflection, but it always appears around the sun. All right, for halo it always appears around the sun. So for halo we also often call it as 22 degrees halo. All right, 22 degrees halo, which is this, something like this. So you can see halo in many places. All right, not necessarily from the ground. You look up to the sky, you can see halo. You can actually see halo from the sky as well. All right, so I share an image which I took a few years ago. So a very faint halo, all right, a very faint halo, sorry, taken when I was in a flight from Penang to Bangkok, if I'm not mistaken. Yeah, so halo from the sky, 38,000 feet above the sky. So for halo imaging, okay, just to add on a little bit, for halo imaging, you does not need a professional or very fancy or very expensive camera. With normal smartphone, current smartphone or your handphone, you can take image with halo. All right, for example, this picture is taken using smartphones. This picture as well, taken using a smartphone. All right, as mentioned by the author, it actually says that this one was captured by smartphone photography on May 29 near Rome, Italy. All right, so yeah, with your smartphone camera, you can easily capture the image of halo. All right, so when you look up, if you realize there's halo, you can try using your smartphones. All right, it's worth a try, and the success rate is very high. You can see it's very easy. It will capture the image of halo. All right, so that's it from me today for the APOD session. So I'll pass back to Jachin to continue with the session.
Okay, thank you, Lai. So next on we have June 6th, another eclipse photo. So okay, so for the eclipse part, Sunit and Lai has already explained a lot about it. But in this picture, another thing that is very interesting is the mirage effect. So sometimes when you see like when the sun touches the horizon, usually you see like it connects the horizon by a bit.
Please post your picture.
Oh, sorry,
Check.
I forgot to share. All right. Now can you see the screen? Can you see the screen now? Hello?
Yes, can see.
Okay, good. Okay, so yes, this is the picture that I'm talking about. So if you see, the interesting part about this picture is the mirage. And usually, the mirage is when the sun touches the horizon, you'll see it bulges up, like here, like here. But in this case, it is the shadow of the moon that bulges up. So this is a very beautiful picture overall. It's taken by Mr. Elias, and yeah, it's a very good picture. Now we have the 5th of June. Okay, so this looks like a very familiar terrain. It even looks like maybe somewhere in Earth, like maybe somewhere in the canyons of Earth. But it's actually taken in Mars. You see here is actually in Mars. And oops. Okay, so the interesting part about this picture is that this is actually taken after sunset on Mars. So, but the night is still bright because of the clouds here. Sunny actually talked about this in one of the previous APODs. This is actually the Nauticus Clouds. It reflects the sunlight from the sun when the sun has already set below the horizon. So the difference between the clouds here and the clouds on Earth is that these clouds is not made out of water, but actually they are made out of carbon dioxide crystals, the dry ice that you use to cool your ice creams when you bring it back from a store. They have clouds made out of those type of ice up in the air. So yeah, it's a very interesting photo. And next we have 1st of June. Okay, so this is the Orion Nebula, but there's a interesting overlay of satellite trails of it above it. It's the June of 1st by Mr. Amir. So the symbolism of this image is that uh, it's about the how satellites affect astrophotography, not just astrophotography, but astronomy in general. Like there has been some, not only recent, but there have been heated debates on like the SpaceX Starlink satellites, like disturbing the process of investigating deep skies using ground telescopes. But we must also not forget how these telescopes actually make our life so much more easier. In fact, like if without these satellites, I cannot even share the astronomical picture of the day through Facebook. So there will be pros and cons to it, and I think there will be some ways to to minimize the impact of this type of satellites. But yeah, these satellites are actually not SpaceX Starlink satellites, because if you know the position of the Orion Nebula, these satellites are not Starlink satellites. These satellites are geosynchronous satellites crossing the sky. So yeah, it's a very beautiful picture. Now I'm gonna pass it back. I think it's Dr. Chong.
Yeah. Thank you, Justin. Bye. Okay. Yeah. So now we go to my first picture, which is on the, you see on top here, 7th of June, 2021. The name is A Bright Nova in Cassiopeia. I will showing the picture later on by Mr. Chad Ayub. He's what I call astrophotographer from Michigan in America. An interesting person. He actually started he's a kind of in IT, a kind of advertising guy. He made a lot of money. He retired early. And how he retired early? Astrophotography, right? So now we go and look at the whole picture. Just a moment to hide the thing. Okay, never mind. Okay. Oh, wait a minute. I have to share. Sorry. Can you see, yeah? Okay. Wait.
Not yet. Okay.
I still cannot see. Can you see the picture now, live?
Yes.
but I don't see on my screen here. Okay, so can you see a light?
Yes, yes, yes.
Yeah, good. So never mind. Okay. So by Mr. Chuck Ayub, a bright nova in Cassiopeia. So Cassiopeia is a constellation in the northern hemisphere, and the bright nova is here. So for people in astronomy, supernova in our lifetime is very impossible because supernova in the other galaxies they occur every year, but supernova in Milky Way is very rare. But nova are quite common. So you see here, recently you have a nova Cassiopeia 2021. So a nova means that it is a star. Say in this case, it's a binary star, a star that is orbiting around the white dwarf, and the material falls onto the white dwarf, and from time to time there's an explosion, very bright, not as bright as a supernova, but bright. And this is recurrent. After so many years later, again the thing from the material from the brighter star falls onto the white dwarf, and then another blow up, another nova. So some of the nova are recurrent nova. That means they occur from time to time. So this is the Cassiopeia, Nova Cassiopeia, Nova Cas 2021, or another name B1405. And it's next to the, Bubble Nebula. I saw the Bubble Nebula. Interesting, huh? So Bubble Nebula is a case of a star that died, and when the star died, it expanded, and from the bubble, the material expanded, given long time, you come to a halt, and it will collapse due to gravity and other effects. New star will be born. So, boys and girls, ladies and gentlemen, our solar system, the stars, the atoms in the body came from a bubble nebula. Not this bubble nebula. An earlier generation of star that died and blew up and collapsed to form solar system. And hey, on the left here, the lobster claw nebula. So this is the claw of the lobster. This lobster. Right? Can see, right? Can you see, right?
Yes, yes, yes. Can see, can see, can see.
Okay, so like this. So very interesting. So a lot of information here. So all these points of light are stars in our Milky Way. So this is looking out. All right. So we go to the next one, which is the 4th of June. Another eclipse moon live for this year, for this month. Okay. So this is, remember, you have our 26th of May. The for Malaysia will be partial lunar eclipse, but in other parts of the world is total lunar eclipse. So this guy, Chirag Upleti, he's actually a kind of a PhD from neurology, from the New York University, and he went to this place called what they call in Pinnacles National Park in Central California, and this is an old tree, all right, dried already, and well, here you have the totally eclipsed moon, all right. So this is called the reddish scattering. So the moon enters into the umbra of the earth part of it, and then you have the red part of the moon. So it's a black moon, and because it occurred in May, you follow the old American farmer's almanac. So during the month of May, the flowers are beginning to bloom after spring, you see, beginning of summer. So it's called the flower black moon, super moon. So this is the old tree, very nice. It looks a bit of a scary feeling. And see, here you see, it looks like the face of a man looking at the moon. All right. So this is it. So that we go to the next one, 3rd of June. There you are. And it's taken by our Ignacio Diaz Bobillo. So this is an Argentinian astrophotographer. And in Argentina, there are so many places to do astrophotography. This is our famous Omega Centauri, what we call globular cluster. Remember, for Malaysia, it's in the southern sky, right? For Malaysia, this is the most fantastic globular cluster. So what's a globular cluster? It's a bunch of stars, looks like a sphere, and they have a central core, and there are many, many stars. So the number of stars in Omega Centauri adds up to about 10 million, right? So these are the so-called population 2 stars. So in astronomy, also got names, For example, our sun, which is in the spiral arm of Milky Way, and which is relatively young, is called the population 1. So population 1 stars are young, and they are able to fuse the heavy element from hydrogen to helium to other from the light elements, hydrogen, helium, to other heavy elements up to iron. So population 1 stars that was found are heavy in metals, but this is population 2. So population 2 don't have much heavy element. So in astronomy, we say that population 2 stars have only about hydrogen, helium, and some of the metals, but don't have so many metals like our sun, right? So this is our globular cluster, Omega Centauri, right? Which is 1 out of 200 globular clusters orbiting the center of the Milky Way, right? But these 200 globular clusters are those that are visible from the Earth. Remember, if you look outwards from the center of Milky Way, you see a lot of globular clusters. But you look towards the center of Milky Way, all the thick dust layer will block the globular clusters on the other side of Milky Way. So we are only seeing on one side of the Milky Way about 200 globular clusters. So actually, in fact, if you can travel all around the Milky Way, you should count many more globular clusters. All right. So this is the population 2 stars in Omega Centauri. And remember, this is taken from Argentina. So from Argentina, it's not looking at the south, vertically overhead, because this is near to the South Pole. So from Argentina, Omega Centauri is vertically overhead. But for Malaysia, you look towards the south, right? We go to my last picture, which is the 2nd of June. Now, this one have a lot to say. Sorry. Now, when I first saw it, now this is June the 2nd. Then I read it up first. The galactic center of Milky Way in stars, gas, and magnetism. So it's in X-ray by NASA, C means Chandra X-ray telescope, University of Massachusetts Department of Astronomy, and Professor Daniel Young. He's an astronomy professor in University of Massachusetts, Amherst, and got radio telescope, National Research Foundation. Now, this is not the American one, no? South Africa. Remember, South Africa is in the forefront of radio astronomy. So this is the National Research Foundation, South Africa, and this is a SARAO, South African Radio Astronomy Observatory, Sarong and Meerkat. Now remember, South Africa is now part of the square kilometer array, no? So Meerkat is the beginning of the square kilometer array. So they built in South Africa many thousands and thousands of radio telescopes, and you combine with another set of many telescopes in Australia to form the square kilometer array. So basically, this picture, you really can enjoy it. Now, I shrink it. I bring it inside. Hey, you're supposed to see words on it, no? How come light didn't come? Huh? Now, on my screen, if I were to put in here, I see a lot of words, So it doesn't appear. Never mind. So basically here, somewhere here is Sagittarius A star, which is the center of Milky Way. So basically, there it comes up. So basically here, it will tell you here that different wavelength will give different. For example, the orange, all right, is in X-ray, all right. So different color is a different material. And then you have here, the white one is not the smoke from the firecracker, no, in the Milky Way, no. This is taken in radio wave by the radio telescope in South Africa, right? And this is a cold gas cloud. Of course, anything that cold gas cloud gives off what? Radio wave. Anything that's very bright is light. That means very, very violent. So basically you have X-ray and it's in all kinds of wavelength given off. So here you look at it's pandemonium, kelam kabut, very, very crazy. What's happening in the center of the Milky Way? So Sagittarius A star is here. So I'm very sure that when it first came out, that the data from this, what do you call this, NASA Chandra X-ray telescope, and also this radio telescope in South Africa will combine together. I'm sure the astronomers must be scratching their head. So many things to study here. And remember, astronomy is not just this object, but it's evolving. It's changing dynamically. So things are still changing. So I'm very sure they will be studying this part of the center of the Milky Way for years to come, right? So very exciting. Maybe here, I would estimate that maybe at least about a few PhDs can be produced by studying the data here. So exciting. Really is so much confusion here, so much confusion, no? Very great, right? Okay, so I stop here. Now you can, okay. So I just end off by saying that, okay, so now I stop presenting. Okay, So our ASP Society has a lot of events still going on, all right, every month. So again, we are going to have, for example, our next APOD session, okay, would be for 31st July. We have to still decide who is to present, 31st July, Saturday, all right? And then, of course, in the coming, in July next month, it will not be on this, in the, what I call, in our YouTube and Facebook, but we are conducting the Penang Statewide Primary School Astronomy Quiz Competition, all right? First round on the 10th of July, second round on 7th of July. So Mr. Lai and I, we are actually conducting it together. So our ASP is co-organizing with the Penang Science Cluster. All right, that's it. And a lot more things to come. So we actually want to...
Dr. Chong, before we proceed, just a reminder to all our audience, just in case if you have any questions, feel free to type it in the comment section so that if we see it, we can answer you all as soon as possible.
Yeah, please do.
All right.
Okay.
Yeah, please do.
No question is say not relevant. If it is relevant, if you want to ask very deep questions, you are welcome. All right.
Yeah, Dr. Chong, we proceed.
So that's all. So as I said, our next APOD session is 31st of July on a Saturday, and then also we also have on our what we call 17th of July, we announce on the second round of our astronomy quiz competition the final winners of the competition. So a lot of nice prizes coming on. Right. So what's the whole idea of this astronomy quiz for primary school? We want to uplift the standard of astronomy in the primary schools in Penang. And we have done last year for secondary school, uplift for what I call this, Penang Secondary School. So we do alternately. This year, primary school, next year, secondary school, and so on. After that, primary school. And we hope that we get support, that we can even organize National Astronomy Quiz. You heard that, Justin and Sunit? National Astronomy Quiz for all the primary schools and all the secondary schools in Malaysia, right? Like this. And of course, we also have things like our, on the 24th July, we have our Astro Chat session, Saturday. And then later on 31st July is the APOD session I mentioned. And then in August, we also have our 14th of August, Saturday, Astro Cafe. And this time, we are going to invite Justin, the 2015 IOAA 5 students, participants from Paris, Prince of Wales International School. So I and Lai Hawk were the team leaders from Penang. And two of our members also joined us. Dime also joined us. And our Emma also joined us. Very nice, huh? And then on the 21st of August, we have our Astro Chat again, which is on a Saturday. All right. And then on 28th August, we have the August APOD session. 28th August, Saturday. All right. So that's about all. So I want to put in this, but Lai corrected me before we started it. We still want to do a session on the China is now building their Tiangong space station, China space station. All right. The 3 Chinese astronauts are now in their Tianhe core module. Later on, more modules of the China space station will dock and will build up the full one. So by next year, 2022, the China space station will be complete. So we and the ASP and our members will also present when the time is appropriate. Maybe in this, maybe in the next month, right? July or maybe August, we present. Okay, that's all. Thank you for attending. Any question, Mike?
So far, I don't see any from both Facebook and YouTube. So I think if not, we can call it a session for today.
Yeah.
So thank you, everyone. Thanks, Sunit. Thanks, Jerchin, and thank you, Dr. Chong.
Thank you, Lai, also. Thank you, Mike.
Yeah. See you all.
Don't go, sorry. Don't go away.
See you all next month in the next APOD session.
Yeah.
And stay tuned to see who will be the next invited guests for our APOD session as well. So that's all for today. Thank you very much. Have a nice night. Good night.